Okay, good morning class. So today we're looking at geometry. Exercise 5 on page 267. We are told that ABCD is a cyclic quadrilateral. We believe ABCD is a cyclic quad. What do we know? We can say that opposite angles are supplementary. There's no exterior angle. And we can also apply the angles in the same segment rule. Not so. Then we are told that AC and BD intersect at P, which is this point here. Is the point at BC such that AE is parallel to DC? If lines are parallel, alternate angles are equal. So that angle is equal to that as well. And many others, okay. Then we are told that prove that AP over PC. Okay, there's now from a different triangle. We can't make a triangle with it, okay? And PE, which looks like it belongs to AP's triangle, over BD. Okay, can you see the two triangles now? So we're going to say in triangle APE and triangle CPD. The order doesn't matter now, but in conclusion it will. Okay. So what can we say about these two triangles? Firstly, angle A2 is equal to C2. Why? Alternate angles are equal. Alternate angles with DC being parallel to AE. Then we know that P3 is equal to P1. Why? Vertically opposite. And then the third one is going to be angle E1 is equal to angle D2. Why? Alternate or third angle of triangle. So therefore, triangle APE is similar to triangle CPD. And my order was correct initially. No? The reason here, angle, angle, angle. So what's going to follow that? We need to then say therefore, AP over CP is equal to PE over PD equals AE over CD. Why? Because triangle APE is similar to triangle CPD. But what do they want? They want AP, PC, yes, PE, and okay, so that's exactly what they want. No? Let's just say therefore AP over CP is equal to PE over P. Okay? You guys understand? In B, they're talking about AP squared. Okay, so is it clear the diagram before I clear the board? So that means you've got AP squared. What does that mean? I must pick up AP twice. So AP is in two triangles, of course. DP, which is this here, and PE, which is this here. Sorry? BP. So it's a double thing. Not so. So you all see the triangles are going to work in. Okay. I'm going to pull this down here. We might need it later. Okay, that's why I'm not going to get rid of it yet. Okay, so B, which two triangles are going to work with? Will be in triangle AP, B, and triangle AP, E. Definitely that order is not right. Okay? So that is the one triangle and this is the other triangle. Okay? So let's start. What can we firstly say there? P1 is a common angle, not so? P1, common angle. What else? C2 is, okay, we remember that that was marked equal there, not so? So you're saying that C2 is equal to P1. Why? Angled in same sig. It is coming from arc AD. You don't have to write this arc here. No? So therefore, A2 has the same marking as angle B1. Okay, so therefore the third angle now, in triangle APE is E1, not so? So angle E1 in this big triangle, I've used B1, I've used P1, so it has to be BAC. Why? Because that's the third angle in triangle. So therefore, APB or ABP, therefore triangle APP. So that angle A is the same as angle, the big triangle APB is similar to triangle. Now the smaller triangle, A corresponded with which angle? A corresponded with E1. Is that correct? Okay. And then B of the big triangle corresponded with A. And then P of the big triangle corresponded with P. This is your common angle. Why? Angle, angle, angle. So what can we say from here? That AB over EA is equal to BP over AP equals AP over EP. Why? Because triangle APB is similar to triangle EAP. But what do they want? They want AP squared. So I'll pick up AP twice. BP and PE. So in other words,
please, I need to know for melee. Can you please
I
report
can
the
cross
answers?
multiply there. Not so.
I need to know for melee.
So therefore
Please report
AP
the
squared
answers.
is equal to BP times PE or EP. Okay. Good solid 6 marks here, people. Okay. It's only if you want it. For B only, about 6 marks. This one is probably 5 marks here. Okay. So 11 marks or something like this. People, question 6. Alright, question 6. We are told that ABC is a trapezium. If ABC is a trapezium, what do we know? AD is parallel to BC. Why? Properties of trapezium. No? One pair of parallel trapezium has one set of parallel lines. So in other words, we could use that. Okay. They want you to prove that AD, there you go again, AD over BC is equal to DE, sorry, over BE. So which two triangles are going to work in? ADE, yes, and BEC. You see the two triangles? So let's go. It's an in triangle ADE and triangle BC. What can we say? Firstly, that line is parallel. Oh, you're saying E1, yes, sorry, you're right. So E1 is equal to E3. Why? Vertically opposite. Right. Now what? A1 is equal to C2. But the line's given parallel. So I must first say AD is parallel to BC. Why? Because one pair of opposite sides parallel in a trapezoid. Trapezium. That's all. That line is parallel to this line. So with that, D1 is equal to angle B2. So D1 is equal to angle B2. Why? It's alternate angles with AD being parallel to BC. Okay? One more. Angle A1 is equal to C2. Why? The third angle in triangle. Or it could have been alternate as well. Not so. So therefore, triangle ADE is similar to triangle. So A corresponds with C, D corresponds with B, and E corresponds with E. Why? Angle, angle. They ever answered the question? No. So I'm going to go with the ratio now. AD, so this is now normally under, no? So AD over CB equals DE over, nope, BE equal AE over C. Why? Because triangle ADE is similar to triangle CB. That's all. So what do they want? They want AD, BC, DE, and BE. So it's exactly like they have it here, not so like we have it. So therefore, AD over CB is equal to DE over. This proven now what they asked for. You will agree with that? Now in B they're asking you DE, which we are already working with. CE, we are already working with that. AE, we are already working with that. So this is actually derived from this as well, not so? Alright, so we can say in B, again we start off with the ratio AD over CB is equal to DE over BE, which is equal to AE over the CE. Why? Because triangle ADE is similar to triangle CBE. That was now proven. But what do they want? They wanted DE, CE, AE, and BE. So what do you notice? What you're going to do here? The cross multiply. So therefore, DE times CE is equal to AE times. Okay? And that is very simple. So any confusion? Okay. This is now number 6. Let's go to number 7. You'll see me take my time with the section of work. It's easy to mix up something. Yeah? You always take your time. The bisector of angle K, what does that mean? That KT is bisecting angle LKT, or K1 is equal to K2. Okay. So if those lengths are equal, okay, no chord. Okay. Interangle KLM cuts LM at H and meets a circle circumscribing. What does circumscribing mean? Is a circle going through the vertex of triangle, or vertices of triangle KLM. KL, which means to say it's inscribed. Can you see that? The circle is going through the vertices of those points. The circle is going through the vertices of the triangle. Okay? At T. The question says, A. Prove that TL squared. So what does that mean? I must pick up TL. TK. This one here. And TH. This here. So do you see the two triangles you're working with? So it's intraangle LTH, which is this one here. And triangle LTK. Definitely the order is not right. Okay. So what can we say first? T is a common angle, yes? What else? Firstly, L1 is equal to K2. Why? Angle to the same segment. K2 is equal to K1Y bisector. Not so. So therefore, K1 has to be equal to L. You all okay with that? So let's go with that. We're saying that L1 is equal to angle K2. Why? Angle in same segment. It's coming from arc T. Don't have to mention that. Okay? Then K2 is equal to angle K1. Why? Given that TK bisect LKE. That was given to us. And then thirdly, we use this, so H1 we haven't used it. So angle H1 has to be equal to angle KLT. Why? It's the angle of triangle. So now, you just put it on the laptop. Thank you, Mr. Shukran. Alright, so we can conclude therefore, triangle LTH is similar to triangle. So you got LTH, which is this triangle here. So L corresponded with K, no? T with T, and H with L. Not so. And the reason here, angle, angle. So now we can conclude the ratio. Not so. Like I say, therefore, LT over KT is equal to DH over DL equals LH over why? Because a triangle LTH is similar to triangle KTL. Okay. So what do they want? They want LT squared. So there's the one and there's the other. KT, which we do have, and TH. Can you see that? So what it is, it's just a matter of cross multiplying. So therefore, TL squared is equal to TH times KT. Okay. Now looking at the B part of the question. B, they're talking about KH. Did we work with KH yet? You know KH here? No? Is that correct? Yes. Right, so which means to say KH, which is this here, KH, there, LT, I've worked with LT, but there is LT, KM, which is this here, and LH, which is this here. So what do you notice? Can you see the two triangles are working in now? Yes. Right. Doesn't look like it has anything to do with this, okay? So what I'm going to do is, I might need it again. So what I do is I just pull this down. Okay? If I need it, then I would pull it up. But I would like to keep the diagram in focus, okay? So let's look at B. I use blue, no? So we use different color, red. So which triangles are we working with? So it's in triangle KMH and triangle LHT. Again, order, this is I'm sure not in the right order. But in conclusion, it must be in the right order, okay? To mark it again, those angles were already marked equal. Right, so in the two triangles, what can we say? L1 is equal to K2. Why? Proven. We already spoke about it, so it's proven. What else can we say? H1 is equal to H2. Why? Vertically opposite. Last one. Angle T is equal to angle M. Why? The third angle of. So therefore, triangle. That is in triangle KMH is similar to triangle. Now KMH, K corresponded with L. M corresponded with T. And H corresponds with H. Why? Angle, angle, angle. Now I can go with the ratios. So therefore, Km over LT is equal to MH over TH equal KH over LH. Why? The triangle KMH is similar to triangle LT. But what do they want? They want KH, LT, KM, and LH. Exactly what we have in that right order. We just need to cross multiply. So therefore Km times LH is equal to KH times LT. Okay. People, if you do enough of this, you shouldn't get it wrong in the exam. Okay. Second last one. We are told that M is the midpoint. M is the center of the circle. A, B, C, D. People, that's the center. What do we know? The angular center is angular circumference, and we also know the radii and all of those things. Okay. So there's a relationship that exists here. Okay. Yes, Michael? No. Okay. Then we told that AB, AD, BD, and DC are chords of the circle. MC bisect. MC, this line bisect angle M. What does that mean? M1 is equal to M2. And B1 is equal to D1. So if B1 is equal to D1. The question says, prove that DB, so this line here, times MC, which is this line here, definitely two different triangles, AD, which is this triangle here, times DC, which is this one. You guys see the two triangles? What's the triangle? So it's in triangle MCD and triangle. This is the big one now, no? ABD. I'm sure the ratio is, the order is not correct. So what can we say? There is the one triangle, of course, and it's now that one, no? And this one is the other. Not so. So what can we say? Angle CS? MCD is equal to? D2 is equal to B2, yes, why? Angles in angles opposite equal sides, radii. Yes, and then? Given, yes. Yeah? Okay, so stop there. You're on the right track. So what she said was B1 is equal to D2. Sorry, B2 is equal to D2. Why? Angles opposite equal sides. Why? Radius. Right. Now you see that B1 is equal to D1. Why? It was given to us. Now if B1 and B2, if B1 is equal to D1 and B2 is equal to D2, therefore ABD, which is the whole angle here, must be equal to MDC. Can you see that? Yes.
So I mean, the way I but you see now, angle is equal to angle circumference.
Yes.
Right now, angle in is cut like acid, right?
Yes.
So then that will mean into
Absolutely. Yes, you're absolutely correct. You all see what she's saying? She's saying that that angle is equal to that angle. Not so? Because what's the size of this angle? Twice x. Then this has to be x. Can you see that, people? So let's say let m1 equal m2, which is equal to x. Where is this coming from? Given that MC sorry, bisect BMD. Okay? So therefore angle A has to be equal to x. Why? If this is 2x, this has to be x. Why? Angle at center is equal to 2 times angle at circumference. So what do you notice now? Remember these are the two triangles I'm in. What do you notice now? Therefore, M2 has to be equal to angle A. Therefore, M2 has to be equal to angle A. One more. Which angle didn't we work with? C. Therefore, angle C has to be equal to angle A, D, B. You all agree with that? Angle C has to be equal to A, D, C. Why? Third angle of triangle. Now, of course, you can go into the ratios now. Not so. No, not yet. So, therefore, triangle MCD is similar to triangle. So, now we go see. M is with A, C, M, C is with D, yes, and D is with B. Why? Angle, angle, angle. So with that, now I have enough to go with the fact that therefore MC over AD equal CD over DB equal MD over AB. Why? Because triangle MCD is similar to triangle ADB. So what do they want? They want BD and MC. And they want AD and exactly like we have it in. Not so. So what do we say? Just need to cross multiply them. So BD times MC is equal to AD times BC. Okay? And that's what they want. More than 6 marks, 6 or more. Okay. So let's look at the second part of the question. So with that in mind, they want, in the second part of the question, AB over, so AB over MD. That's definitely a different triangle. And BD and CD. Okay, so BD actually belongs to the big triangle, no? Let's go again. AB, DM, BD, which belongs to that one there rather, and then CD. Didn't we just work with this now? Yes. Okay. Exactly what we worked with. So, I'm going to take this off here. This is now for B, no? We know that. Same ratio. MC over AD is equal to CD over BD equal MD over AB. Why? Because triangle MCD is similar to triangle ADB. Right, let's see what do they want. They want AV, MD, BD, CD. But what did they notice? What do you notice? It's flipped. Not so. You flip the script both ways. So therefore, BD over CD is equal to AB over. Yeah. Simple. No? Last one. Yeah, I thought you would never reach here. People, we are told that MR is a tangent. If MR is a tangent, what do we know? M1 is equal to angle P. That's T. Why? Tan cos theorem. Chord ST is produced to R, which means to say ST, the TS, is extended to R. Suppose that means TS, not ST, no? But okay, it's fine, probably. A, prove that Rm squared. So what does that mean? Use it twice. Rm squared, so it will be that, and it will be, I try to distinguish between the two triangles like that. RT, so this one here, and RS, which is this one here. You see the two triangles are working. So let's go with that quickly. In triangle, RMT, and triangle, RMS. So what can I say? Angle R is a common angle. Then M1 is equal to angle T. Why? Tan cos here. And then S1 has to be equal to RMT. Why? The third angle of triangle. So therefore triangle RMT is similar to triangle. So RMT, the big triangle. So R corresponds with R. M corresponded with S. And T corresponded with M. Why? Angle, angle, angle. So now we can conclude, therefore, Rm over Rs is equal to Mt over Sm equals Rt over Rm. Why? Because triangle RMT is similar to triangle RSM. Right, so what do they want? They want Rm squared. So these two Rms. RT and Rs. So it is a matter of cross multiplying, not so. So therefore Rm squared is equal to Rs times. Then the last part, B, we are told that, so definitely I don't need this here. We are told that if Rs is X, Rs is X, Rs is X, and Ts is 5. Ts is 5. So what is RT? X plus 5. Rm is 6. No, Rs is X. The length, calculate the length of Rs, which is X. If Ts is 5 and Rm is 6, Rm is 6. Okay. So if we look at this here, we know that Rm squared is equal to Rs times RT. So Rm is what? 6 squared is equal to R is x times RT x plus 1. So it becomes quadratic now. So it's x squared plus 5x minus 36. So let's take this here. So it's 1, 5 and negative 36. It's 4 and negative 9. So x is 4 or x is negative 9. Can x be negative? No. So therefore R is, which is x, equals 4 units. Alright, people, you guys are writing Tuesday. It's now over for the weekend. Please prepare for the exam. Enjoy your weekend. Good afternoon, class.